First of all, thanks for coming to this talk. Lunch went well today, so I hope you're all relaxed and ready to hear about some Rustdoc trickeries. We'll be talking not necessarily about writing code, we'll be talking about analyzing existing Rust code, which is a problem that you start to get into when you have adopted Rust and your scaling is usage. But before we go into the nitty-gritty details, let me get introduced. I met some of you in the hallways. For those of you I haven't met, my name is Luca Palmieri, and I work as a principal engineering consultant for Matter, so the company organized RustFest, EuroRust. That's in partnership. We do Rust consulting, Rust training. I was doing a workshop the day before yesterday, so if you are thinking about adopting Rust or thinking about needing help on some Rust projects, come talk to me. Said that, I've been in the Rust community for 5 to 6 years. I've been contributed at various open source libraries, open source tools, and I'm probably best known for being the author of Zero to Production in Rust, an opinionated introduction to getting folks started with Rust for backend development. Now, down to today. The talk is split into 4 sections. We'll talk about what it means to succeed at adopting Rust and what new problems Rust brings with it. We'll then oversee some of the different techniques that you can use to analyze Rust code and explore, in particular, Rustdoc JSON as a potentially promising alternative for building tooling. So, you want to do Rust, you need to build a new system, you're your company, you're the Rust evangelist. You spend a long time convincing, grinding down all the people, saying, we should use Rust. Eventually, they concede, and so you spend months, weeks, whatever that is, writing Rust. And at the end, you're now responsible for tens of thousands of lines of Rust. Some people on Reddit would say congrats, other people would say condolences. What do you do with this Rust? That is the question. Because when you have so much code, questions that become trivial in a small code base actually start to be quite tricky to answer. Like, how do you reason about all that code? For example, let's go through some of the questions that my past self has wanted to ask about fairly big Rust code bases. If you're maintaining a library, this could be a crate on crates.io, this could be a library that is internal to your company, that is exposed to other folks. You want to have very tight control about the stability of the API that library exposes. Part of that is which crates do you expose through your own API? Because if you use types from your dependencies in the public API, they become part of your guarantees. If they release a breaking change and you update that library, you are also breaking the contract for your users. So you want to have very tight control over which types are exposed from which crates. This is easy if you have a mod.rs and a few more files. If you have 10, 20,000 lines of library, that is not as easy. It's not something you do manually, because if you do manually, it's error-prone, and sooner or later you get it wrong. You might want to ask yourself, does a certain module depend on another module? This is very important when you're trying to implement design patterns. Like perhaps you're trying to do a repository pattern for a database. Perhaps you're trying to do hexagonal architecture, and you want to have some inversion of control. And you want to make sure that the implementations depend on the interfaces and nothing leaks through. How do you do that? Question. But then you might get into more some specific use cases. So I do backend, I do a lot of cloud native. Which endpoints require authentication? Easy if you have 5 endpoints. Not as easy if you have 200 endpoints, and these applications exist. And you might want to know in a PR, does this PR make an endpoint that used to be auth-protected, auth-unprotected? How do I find out? Because the opposite is usually fine. Overprotecting might be a bug, but it's not as risky. Exposing an admin API that was supposed to be for internal employees, that sometimes can have pretty severe consequences. Or other times, you might have a large monolith. You have a big application, it's written in Rust, started out as a single app, was maintained by one team. Now you have 30 developers. You want to break out parts of that application. And you also want to break out the state. You don't want microservices reading and writing from the same database. That's recipe for problems or very interesting challenges, depending on the viewpoint. And so you might want to say, OK, this database needs to do some user management. Which endpoints touch this table? Tough questions if you have 200 endpoints. But these kind of questions are the interesting questions that you are faced with when you actually succeeded at adopting Rust. You got to use the shiny new tool. You've wrote yourself 100, 200, 500,000 lines of code. What do I do now? And a common answer to these problems, which, to be fair, I agree with, is to use the Rust compiler. So you're like, I don't have to worry about analyzing if something bad is happening, because I'm going to design my code in such a way that the bad stuff just doesn't compile. And while this is generally like a strategy I advise, recommend, and employ, is not necessarily always possible or desirable. Sometimes the invariants you want to enforce cannot be represented in the type system. Other times they can, with sufficient trickery and disregard for, I don't know, your users. But the reality is that they're not necessarily nice to use. They might make the API a lot more complicated, which in turn slows down development of folks using those libraries. Or they might result in an API that's great on the happy path. You look at code that compiles, and then it's like, yeah, nice code. But when the code doesn't compile, you get welcomed by a few pages of type errors. I think we've all been there, depending on which crates you like to use. And you're like, I think I need a PhD in Rust to debug this. That is not nice. So let's explore when this fails, right? Or you don't want to do it, because you're like, I don't want to inflict this pain on someone else. What can I do? What are my options when the compiler cannot help me? And this is where we get to the second part. Because in the end, we want to have something that takes code as input, and manipulating code in Rust, which sounds, rhymes with metaprogramming. And Rust has some metaprogramming facilities, which are macros. And we have two types of macros. Macro rules, also known as macro by examples, and procedural macros. Let's start by macro rules. These are primarily geared towards code generation. How many of you have used a macro? Yay, down. How many of you have written a macro? How many of you have written a procedural macro? Less hands. OK. Cool. So I'll review it very fast, and then we'll go through it. So macro rules is a match statement for code. Like, you have the name of the macro. This time it's times 10. And then you have a bunch of patterns that the code that is fed into the macro may match. And depending on which pattern matches, you generate a bunch of other code. Simple on the surface, but like all simple things, it's quite powerful, because the macro can invoke itself, TT munchers, patterns, crazy things. Like, you can do a lot with macro rules. But primarily, you're doing code generation. Code comes in, a lot more code comes out. This is generally the pattern. Now, procedural macros are more interesting, for a specific definition of interesting. Let's look at one example, which I happen to write very often. Instrument from the tracing crate allows you to open a span every time you call a function. Now, the macro arguments here are the ones that are passed into the instrument as between parentheses. And then the item that the macro applies to is also input to the macro. So all of this gets converted into a function that looks like this. So you have the name, proc macro attribute that says this is a proc macro. You're getting a bunch of args. You're getting the item the macro was applied to, and you're supposed to push out the code you want to generate. As the name of the type implies, tokens in, tokens out. Now, let's take a software architect from the 90s approach, and let's write some boxes and arrows. What is a proc macro? Proc macro is some computation that takes as input tokens and outputs output tokens. The reality, though, is that a proc macro is a Rust program. As all Rust programs, as we found out over the years, can do whatever it wants. So in reality, if you're feeling spicy, you can do some side effects. What kind of side effects? Well, first of all, when you read procedural macro, always think in your mind, arbitrary code execution that runs a compile time with localized input if you're being, playing by the rules. You could, for example, take the input to your macro and save it to a file. So for example, you could go and annotate all your queries with a proc macro, store that into a file, and then you could go and analyze all the queries. And that would tell you, all the queries coming from these modules are touching the users table. And you could infer, OK, this part of the application touches the user table. You could also do some network calls to fetch resources. This is what the sqlx crate does. You want to validate that your queries are right. I'm going to issue prepare statements to your database. And your database is going to tell me, yeah, these are good queries. No, these are not good queries. And it's all very cool, but fundamentally limited by the fact that you're working with tokens. What does this mean? Let's go back to the query example. So you have a select star from users. And you could write this as SQL_query bang query inline. And that would work, because you would save to the file the actual query. Now, you do some refactoring, because dry is good, and you want to assign stuff to variables. And now query is a constant, and you're passing query into the macro. Well, the reality is that this doesn't work, because what the macro receives is a token that says query. There's no way for the macro to actually go from query, the token, to the constant that is associated to the string. Now, reasonable person may say, I mean, it's fine, right? The compiler knows. So the macro can ask the compiler, please, can you tell me what query is? The reality is that Rust does not have any reflection API, and in particular, no compile time reflection API. Now, those of you who spend too much time on Twitter probably are aware of the RustConf situation around compile time reflection, and we're not going to talk about that. But the reality is that this doesn't exist, and there's no practical, short-term plan to bring this into existence. So macros are fundamentally limited to analyzing at the AST level, can't really do any type-aware computation. Now, those of you who are very devious might say, in the end, it's just code. So you could say, even if the compiler doesn't give me any specific API to go and resolve this token, in the end, the compiler is a bunch of Rust code. I could use the compiler as a library. Now, if you go on GitHub, this is what the Rust compiler looks like at the point in time where I prepared these slides. And as you can see, it's a fairly complex beast. I think there's like 40-something crates. And this is all unstable. Like, the Rust compiler as a binary artifact has very good stability guarantees, make sure that code that was written 5 years ago compiles today, but the compiler internals are internals, and they change as quickly as is necessary for the Rust project to ship whatever they want to ship. And so if you try to depend with these APIs, you're exposing yourself to a massive amount of instability. And the reality is that you spend more time trying to keep your code compiling, because it's using all these internals, than actually trying to solve the problem that you want to solve, which is fundamentally the problem with stuff like Rust C plugins, which would be very nice to have unstable. So all is dark, there's no hope, and there's no solutions. But something came out roughly a couple of years ago, which is called Rustdoc JSON format. Now, let's do a psychological experiment. If I say Rustdoc, what comes to your mind? Visualize it. In my mind, I get this. When I say Rustdoc, it's docs.rs. So it's where I go to get all my documentation. Very nice, very nicely integrated into the Rust toolchain. One of the big nice things about Rust. Now, boxes and arrows again. What's Rustdoc? Rustdoc takes a Rust crate as input, does some stuff, and gives you HTML. But we can add another box and gives us JSON. Now, the good thing about JSON is that it's machine parsable. Now, if you think about Rustdoc, what is Rustdoc actually doing? Like, Rustdoc is exposing to you, in a web page, a lot of information about the API of the Rust crates that you're using. What functions are exposed, what modules are exposed, what types they take as input, what types they take as output, which traits are implemented. Like, you find a lot of stuff in there. But obviously, parsing HTML is not as nice. JSON, on the other kind, is actually quite interesting. Now, this feature was introduced in an RFC in 2020, implemented shortly afterwards, and is currently unstable. But it has a very clear path to stabilization, and is slowly working towards that. We might expect that to happen in a relatively short time frame for the Rust project. So nobody makes promises, but let's say perhaps a year, a couple of years. And you can try this yourself. So you go cargo, you say, I want to use the nightly channel. Then you say Rustdoc. In this case, I want to document my library. I want to use the spicy options. And then I say output format JSON. And this gives you a JSON file. Now, this is not as scary as it may sound. Let's look at an example. I'll take a struct from a crate I maintain, cargo chef. It's a very stupid struct. Which arguments do you want to compile for? You might want to compile your benchmarks. You want to compile your tests. You might want to compile your examples. You might want to compile everything. What does this look like in Rustdoc JSON? Looks like this. So let's break this down step by step. Every item that is exposed inside the crate gets a unique identifier. Is that 0:12:1620. The ID can be broken down into subcomponents. The first one is the crate ID. The crate you're generating documentation for gets assigned the number 0. So since I'm documenting Cargo Chef is crate ID 0. So this is telling me the item you're looking at was defined in this crate. Then I get the name, target args, which was the name of the struct. I get the visibility. This case is public. This might be private. This might be pub in module, all the usual modifiers that you're used to. And then this is an algebraic types, obviously flattened into JSON. So there's a discriminant, which is called kind. In this case, we're looking at a struct. So inside inner, we find fields which are specific to structs. Structs in Rust have different types of structs. You can have a unit struct. You can have a tuple struct. You can have, oh, I'm losing pieces. No, OK. You can have a plain struct, which is a struct with fields. And this is a struct with fields. So you just go, OK, what are the fields? And you have all the different fields in there as identifiers. So this is a kind of a normalized schema, if you want. And then, structs can have generics. In this case, it's not generic, so that is empty. And structs have implementations. Implementations which may be inherent. So you're doing like imp, target args, and adding new and a bunch of methods. Or implementation blocks, which might be related to traits. I'm going to implement default for this type. And all of these have themselves identifiers, which you can find in that list at the bottom. And you can follow the IDs, like following the spiders. And you can go, for example, look at a struct field. So we could go and say, OK, let's look at one of those fields. And you get this benches field. Once again, ID, create ID, name, visibility. This time, the kind is not struct. It's a struct field. Struct fields have types. This is a primitive, and this is a Boolean. So, all stuff that it's very mundane. Like, it's the stuff you're used to by looking at documentation. There's no secret. It just laid down into a schema in a machine-parsable format. The cool thing is that you generally don't even need to look at the JSON. So the Rust project is something very nice. There's a crate called Rustdoc types. And this is maintained in tree inside the Rust repository. Every time the Rustdoc JSON format changes, because it's slightly unstable, you get a new release of this crate. This crate implements this SERD, the serialized crate, generate, deserialize, and then from there, you are working with like Rust structs. So it feels very similar to working with Sin. Obviously, it's a more representational format. But if you're used to do macros, this feels very close home. Now, the other thing that is really exciting, and one of the reasons why very often, like, people are recalcitrant to add APIs for reflections in Rust, is that you don't want to oxidize the language. Well, that's a bad word. You don't want to fix the language in place. You don't want to make it so that Rust can't change its syntax or can't evolve over time. And Rustdoc JSON format is a version format. So even though it may be stabilized at a certain point, that doesn't necessarily mean that it has to stay fixed. And that goes back to what Nico was saying, which is stability without stagnation. We want to give people tools, but we want to allow those tools to evolve over time to fit the needs. Now, this is all very theoretical. Perhaps, it looks cool, maybe, I hope. But what can we actually do with this stuff? Well, there's a lot of things already happening, even if this tooling is, at the moment, on nightly. So let's go through some of the tools that you can pick up today, which are built on top of this. Number one, and definitely my favorite, is called cargo assembler checks. So every time you're maintaining a library, a big concern that you have, as we mentioned at the beginning, is trying to understand, am I breaking the API with this PR? Is that intentional? So do I want to do a breaking release? Or am I fixing a bug and perhaps subtly breaking some parts of the public API that folks may depend on? Cargo assembler checks works conceptually very simply. You take the existing released version of your code, generate the JSON. You take the version in the APR, generate the JSON, and then run a bunch of queries checking these two JSONs one against the other. Is there a field in main that was public that is not in the APR? Break and change. Did something implement send in main, and now it's not send anymore? Break and change. And a lot of more subtle, funny ones that you start to find out when you think about this. The author Predrag has published several blog posts about this, and this tool has already found several SEMVAR violations in very popular crates in the Rust ecosystem. So it's showcasing that if we give people the tooling, we can transform a bunch of things that so far where maintainer needs to be careful into, I have a machine assistant, very much like the compiler, that can support me in making sure that SEMVAR is not broken, similarly to what tools like Elm can do, which is very cool. You then have stuff like cargo check external types. This solves the problem I mentioned at the beginning. What third-party crates are exposed as part of my public API? This tool finds out. You give it an allow list. You say, I want to expose SERD deserialize, SERD deserialize. I want to expose, I don't know, Tokyo task. It's going to generate the JSON for your crate. and go through all the public items and accumulate the list of items that are not coming from that crate ID 0 that I mentioned before. And then it goes to the allow list, and it says, OK, this can do, cannot do. Problem. This is used by the AWS SDK team for the Rust SDK. I don't know if you have opened some of those crates. They also serve as stress tests for the compiler, the AWS S3 SDK. I don't know how many thousands of lines of code that is. But this is the kind of challenges I was mentioning at the beginning. Like, when you're doing this stuff at scale, you can't be careful. You need to have tooling. This is tooling that was built for that. And last but not least, this is my project. It's an upcoming web framework that you cannot use today, but it uses Rustdoc JSON. You pass me a bunch of stuff. You pass me route handlers. You pass me constructors for types, error handlers. I go, I generate the Rustdoc JSON, find out what the inputs are, find out how to build them, find out if they need other inputs, build a graph, and then generate a bunch of code that's going to do the runtime behavior that you want. A little bit like dependency injection in ASP.NET Core and similar frameworks if you come from those ecosystems. Pretty much, I wouldn't say impossible to do in stable Rust, but very difficult. Cool. That was the hype section. Like, this is cool. Now I tell you all the ways in which this is not the final solution to all your problems. Well, yes, it's not a silver bullet. So, while some pieces of information are exposed through Rustdoc JSON, they might not necessarily be easy to consume. For example, you want to know, does this specific type implement a certain trait? Well, that is not easy to answer, because if that type is generic, where does the trait implementation come from? It might come from a blanket implementation of the trait for like a certain T that verifies certain bounds, which your type may verify, and so it does implement the trait. Or it might have an imp path T, but T needs to certify certain bounds for that to apply. You soon realize you are implementing your trait solver, which is, it's a fun side project, but perhaps one you don't want to start. So yes, all the implementations and the traits are in the JSON, but actually performing this kind of queries is very complicated. Other information is just missing. When you go on Rustdoc JSON or Rustdoc HTML version, the one you're used to, you see signatures, function signatures, type signatures, stuff that is public API that you can use. But you don't have anything about function bodies. So let's go back to what I asked you at the beginning. Does module X depend on module Y? You can answer a weaker version of this question. You can say, is there any API in module X which in its signature has elements from module Y? That one you can answer, because you see all the signatures. You see the functions, you see the implementation, you see the methods. But you have no idea if inside a function body, module X is calling a function from module Y. You don't see function bodies. That requires deeper introspection, which you don't have. Said that, I am very hopeful. Like, the community is transitioning from trying to convince the universe that Rust is a good idea, which we should keep doing, to, yes, everybody agrees that Rust is a good idea, so we're writing a lot of Rust code. And what that naturally is going to bring to is that we need better tools to analyze that Rust code. We're getting better IDEs, we need better static analyzers, we need better ways to do introspection. And so these tools enable these tools to be built. They'll have limitations, but people will have the hunger to have more, and this cycle eventually will lead to cool stuff. So all in all, pretty hopeful, I think. Said that, that was the end, and if you have any questions, I'll be right there, so come and ask me.